All right, so we're going to pick up where we left off in section 6.2 last time. We were talking about addition and subtraction of rational numbers. And as we move into example 6, I want to remind you of what we had done in example 5. And in example 5, we looked at two different ways of seeing how to combine fractions together, right? Mixed numbers specifically. One way was to make them all improper, and then use our properties of fractions, and then get a value, right? And then when we were at the end of it, we turn it back into a mixed number because it started out that way. The other option was to deal with the mixed numbers sort of independently. The whole number pieces, deal with them separately from the fractional pieces. Does everybody remember doing this? Okay, so we're going to be doing another example of that on example 6. And so over here, we have Martine. It says that she bought 8 3/4 yards of fabric. If you've ever bought fabric, this is a super exact kind of a application kind of thing. This is what you do. You go to the store and you tell them how many you need in yards. It's always in yards. Don't know why it's in yards, but it is. So she buys 8 3/4 yards of fabric, and she wants to make some different pieces of clothing. She wants to make a skirt using 1 7/8 yards, pants using 2 3/8 yards, and a vest using 1 2/3 yards. And the question is, how much fabric will be left over? So what Martine would really do is she would lay out her fabric, and she'd cut off a piece that's one length, right? And then she'd have the leftover piece, and then she'd cut off a piece that's another length, and she'd have this leftover piece, and she'd keep doing like that. So what she would literally do in terms of the values here is that she would actually start with 8 2/3, and she would subtract off the 1 7/8, and there'd be a value, and she'd get that value, okay? And then she would cut another piece off, which was the 2 3/8. And then she'd cut off her last piece, which is her 1 2/3. And we'd figure out how much she had left. Right? That's the description here. Does that make sense?
Does it start with the 8 3/4?
Oh, I wrote it down wrong. I'm sorry. Thank you. Yes. So just so you guys know, the reason that this is going to happen, and you got to keep me on toes, is because I zoom in a lot and I lose things on my screen to make them larger. So if you notice me getting values incorrect, I've probably zoomed somewhere I wasn't supposed to zoom. So did I get all the rest of them okay?
Yeah.
Okay, perfect. Okay, so this is what the description is that's given, but this is really not the easiest way to sort of manipulate and do this particular problem. Can you think of an easier way than repeatedly subtracting these different values that have different denominators and it's kind of messy looking? Okay, well, a different way of thinking about it is that she's got all these pieces of clothing or projects she's going to work on. Instead of subtracting them off of the total amount of fabric one at a time, we could add up all the pieces she's working with together first and then subtract them from the amount she started with. Does that make sense? Now, you may be looking at it and saying, well, that's basically doing the same amount of work. And yes and no. In some sense, that's true. But the reality is that subtraction is a little bit harder to do than addition is. And that's actually the reason why it's a little easier to add these pieces of clothing up first and do the subtraction second. So I'm going to suggest, instead of doing the way that we have it written here, we're going to do the 8 3/4, and we're going to subtract off what happens after we add up the 1 7/8, the 2 3/8, and the 1 2/3. Is that okay? Now, hopefully, as well, as you're looking at this from sort of a property kind of standpoint, you can see that what it looks like I did is just pulled the negative out in front and changed all the signs inside. That is a true statement. You can think of it that way as well. Now, this is nice to some degree because if you notice, two of these values have the same denominator. So that's not altogether bad to start with. So let's actually start with them because those values are pretty nice to go together to begin with. So if we have here 8 3/4. So you can do mixed numbers or you can do improper fractions. I'd like to do the mixed numbers one again because that's the one that was least familiar to you guys when you raised your hand and said, this is the one I've seen more frequently when we talked about it last time. So with mixed numbers, what we do is we add together the whole number pieces first. So 1 plus 2, and we could even do it with the 1 at the end. We might as well. They're all whole number pieces. So I have 1 plus 2 plus 1, which gives me 4. The 7/8 and the 3/8 can automatically be added together very nicely because they have the same denominator. I have an 8. What would their numerator then be? 10. Yep, 7 and 3 is 10. And then we still have the 2/3 at the end. Is that okay so far? All right, cool. 2 choices. You can reduce the 10/8 if you wish, or you can combine the 10/8 and the 2/3 together first. Do you want to reduce first or do you want to combine first? Reduce. Thank you for making a decision. I appreciate it. So if we reduce, most of the time I just need you guys to tell me an option. We can move forward. Okay. So if we reduce, what can we simplify both the numerator and the denominator of 10/8 by? 2. So we can divide these both by 2. So let's do that. So we have 8 3/4 minus, I still have my 4 here. Now I have 5 over 4 plus 2 over 3. Okay, everybody good? All right, those 2 fractions are in reduced form now, so we can't do any more sort of simplifying before we move forward. We can add, we can add them together by doing our multiplication across the diagonal. So again, 8 3/4 minus, here's my 4, and then I have 5 times 3, which is 15, plus 4 times 2, which is 8, over 12. Okay, is that all right? Lovely. So we have our 8 3/4 minus. So this is a 4 at the beginning. What's 15 plus 8? 23. Thank you. 23 over 12. 23 over 12 is top heavy, so it's improper already. In addition, it's not very friendly to sort of say, okay, well, let's combine these together. I can do 8 minus 4, and then I can do 3/4 minus 23 over 12. It's not super friendly the way it is. So I would probably suggest, for the most part, kind of like when we reduced the fraction in the middle of there, that we go ahead and change this into a mixed number in the middle of here as well. Okay, it's not going to solve all of our problems. We're still going to end up with something a little odd happening in a moment, but it cleans things up a little bit for now. So I have my 8 3/4, and I have the 4. Well, I have the 23 over 12. So if you take 23 and divide by 12, how many times will it go in? 1 time. And if I subtract my 12, what's 23 minus 12? 11. So this gives me over here the same 4 I already had, plus the 1 at the top, and 11 over 12 at the end. So the 4 was already there. The 1 came out of the mixed number, came as a part of the mixed number that I just created, so I have 5. So this is 8 3/4 minus 5 and 11/12. All right, so here's the deal. At this point, I need to subtract whole number pieces and fractional pieces. Like, that's fine. So we've got 8 minus 5 going on. And then we have 3/4 minus 11/12 going on. Everybody good so far? Okay, 8 minus 5 is 3. This will go faster if you guys say the answers real quick, okay? The next one, we could do this where we've been doing it like that before. We could do that. There's nothing wrong with it. It doesn't really need to be done. It makes things kind of large. That denominator, if I multiply 4 times 12 is 48. It's kind of a big denominator. So this is one of those cases where looking at the denominators to see if there's any way to simplify them to a similar, a common denominator quicker might be helpful. In particular, if I multiply 4 by what will I get 12? 3. So this is a really good place to do it in a slightly different way. Again, if you don't think to do it and you do it the other way, that's fine. No harm, no foul. It's fine. It's just going to be a little bit bigger of numbers to deal with. So now on top I have 9 minus 12. And on the bottom, because they're both the same, I have 12. So this is 3 plus. Okay, what's 9 minus 12? Close. Negative 3. Negative 3 over 12. All right. So this is one of the sort of drawbacks of doing it in this mixed number approach.
Is that supposed to be a 12 or an 11?
Did I have a typo on one?
Well, you just have 11 over 12 there. And
It's supposed to be an 11. Thank you.
Okay.
Yep. Thank you for catching that. So I have 2. Is that right? Better?
Yeah.
Cool. Thanks. Okay. All right. So the problem still remains the same problem. And so, well, in the sense that we've got a thing we have to deal with, right? We are taking a whole number piece and we're subtracting off a fractional piece. When they're added, like when they're both of them positive, we just push them together and the answer's done, right? That's what happened over here. We just pushed the 5 and the 5, 6 together and we were done. But when there's subtraction, you can't just push them together and call this done. You have to do something a little differently. Now, before I do that, would you like to reduce the 2 and the 12? Okay, let's do that. What will 2 and 12 both divide by? 2. Okay, let me make this a little bit smaller so we've got some more space to work. Okay, so we now have 3 minus 1/6. Is that okay? Yeah? Okay. So here's what we do. I want you to imagine, we don't have money that works like this. This isn't a very good example. But imagine this just says 3 minus 1/4 so that we can talk about money. Okay, so if you had 3 minus 1/4 and we were talking about money, what is 1/4 of a dollar? What is that? 25 cents. It's a quarter, right? So let's imagine you had $3, okay, and you had to take away a quarter from it. Can you picture doing that? Okay, what you would not do is take your $3 and turn them all into quarters, give somebody a quarter, and then turn all the quarters back into dollars, right? You wouldn't do that. That's an unnecessary step. What would you do? You would take $1 and you'd turn it into quarters. Are you with me? We're going to do the equivalent of that right now. We're going to take the 3 and we're going to take away one of them. So we're going to have 2 left. And we're going to turn that one that we took away into quarters. Well, in this case, into sixths. I will have 6 sixths because that's the same as the number 1. Why would I want to do that? Well, because now I have 6 sixths that I can take away 1/6 from. Are you with me? You now actually have 4 quarters, or the equivalent of, in your pocket, and it's easy to just remove one of them, give it to whoever, and now you still have the 3 quarters that are left. So what is 6 sixths minus 1/6? 5 sixths, and we still have the 3 at the beginning. Units, what was this? Yards. We need our yards at the end to have.
2. Why is it 3?
2, because I'm zooming in and I'm zooming out. This is going to be one of those days. Somebody should keep track. All right. All right, yards, thank you. 2 and 5 6 yards. Oh, the good news is that's what my paper has on it too. So we're all on track now. All right, does that make sense? Okay, so if you don't like this mixed number approach, it's really very messy on this one. You're welcome to do the improper fraction approach. It's also going to be messy. I'm not lying to you. Both of them are really messy for this one. If you decide to do improper fractions, you can do it from the very first piece that we did. If you want to do it from here, you could do that. You could do it from this piece where you're adding the pieces together first, and you could do it that way. But you got to get common denominators. You got to turn all of the fractions numerators. You end up with some really big values. It's messy no matter what you do in this particular one. All right, we good? Okay. The last thing in this section is estimation. So estimation can be done in lots of ways. We're going to talk about convenient fractions. So convenient fractions are fractions that are roughly equal to what we're given, but they're easier to work with. So some examples of convenient fractions are listed here. 1/2, 1/3, 1/4, 1/5, 2/3, 3/4. And 0 and 1, which are not technically fractions, also sometimes are close enough to the values we're working with that we might use them. Okay? Now, there's some questions, in your book where they actually say to estimate which fraction is the closest to estimate, and they give you like 5 to choose from. It's almost like a multiple choice question. So I'm not insinuating that you have to come back to this list. There's nothing special about this list. This is just a few examples of things. Some of the ones in your book, they actually tell you to pick from among these 5 options, which one's the closest. So just make sure and pay attention to the directions. But if you're not actually given what should you pick from, you can also just estimate by trying to turn it into one of those things that looks like an easier to deal with fraction. So we're going to do a couple like that. So the first one is 12 over 78. And what we're going to do as we work with this is we're going to try and change the numbers to make the fraction sort of cleaner. For example, the number 12 is really close, honestly, to the number 10, isn't it? It is. And the number 78 is pretty close to the number 80. And if you have 10 over 80, this is actually the same as having 1 over 8, because you can divide them both by 10. 1 over 8 is a pretty convenient fraction. Notice it's not actually on my list, right? But it's a pretty good approximation for this particular problem, and we're not given anything to say we have to choose one of those ones. So this is pretty good. It's a little harder to justify if your estimate is high or low. Now, one of the things that, remind me your name? Ruth. That Ruth had mentioned was, can we use decimals? So to give yourself some sort of intuition of what's going on here, you could. But to justify it, like write down, like, why do I know for sure? You can't, okay? So if you would like to check 12 over 78 and 1 over 8 and see which one's higher or lower, and turn it into decimals, you can do that. But I'd like to talk to you about why or how you can do it by looking at the values themselves, not looking at a decimal approximation for them, okay? So let's just talk about the numerator first. If you take 12 and make it into a numerator that's the number 10, just that thing only, did the fraction get smaller or bigger? It got smaller. So the change we made on top, this change right now here, made things smaller, correct? Just the 12 to 10. What happens if you make a denominator bigger? Okay, so think about the denominators. Like, so if I had 1/3 and then I made it 1/4, does the fraction get smaller or bigger? It also gets smaller, right? You're dividing something into more pieces. So if the numerator makes the fraction get smaller and the denominator makes the fraction get smaller, then what has happened at the end here is that this is a smaller fraction than what I started at. It's smaller than my starting fraction. So if it is smaller than my starting fraction, is 1 over 8 a high estimate or is it a low estimate? It's low. It's smaller than what I started with, so it's a low estimate. So that's great if it makes it smaller to smaller on top and smaller to smaller on bottom. Like, that's wonderful, but what if one makes it smaller and the other one makes it bigger? Well, that's a more difficult thing to have to justify, okay? So when that happens, and I think that will happen on your homework on one of them, you're going to have to think of some other options of how you know. Let's take a look at another example that's a pretty clean one for the moment. The number 2 is still awfully close to the number 1. So I'm going to put it, I don't mean equals, approximately 1. The number 1001 is awfully close to the number 1000. If you want to leave the numerator the same, you could even do that. That's not too bad. Leave it as 2 if you wish. I'll leave mine as 2 this time. 2 over 1000 reduces. What does it reduce to? 1 over 500. So if I had left mine the way I did it before, I would have said 1 over 1000. If we've done it the way I did it right here, we've say 1 over 500. Both of those are estimates, and both of those are convenient fractions, and both of them would be considered correct. Okay, so there's not a one right answer on this particular one. Maybe not even one that's intuitively like better than the other one kind of thing. So this one, though, if I did it this way, since I only manipulated the bottom got smaller. So what happens when the denominator gets smaller? The fraction gets bigger. Okay, I made a bigger fraction when I made the denominator smaller, which means that this then is a high estimate. All right, so that's where we're going to stop today. We have about 8 or 9 minutes left still for group work, so we're going to do that next.